Good afternoon, everyone. I am Aarthi pursuing PhD in SASTRA deemed to be university under the guidance of Dr. K. Geetha ma'am. Today I am going to present our work, an automated cervical cancer detection mechanism using PAP smear images, in which Dr. N. Sasikaladevi ma'am from SASTRA deemed to be university and Dr. C. Mala ma'am from NIT Trichy are the co-authors of this proposed work. Cervical cancer is one of the predominant type of cancer in women over 30 years. In India, statistical results reveal that of all cancers in women, 6 to 29% constitute cervical cancer. This work focuses on the pap smear single cell image classification using deep learning model, especially CNN. This is the simple outline of my presentation. First, I start with aim and objectives of this proposed work. Next, I explain the limitation of the existing framework for pap smear single cell image classification. Then I focus on the proposed methodology with the analysis on Herlev dataset. Finally, I concentrate on the results of the proposed methodology with performance metrics and comparison of the existing framework with the conclusion. Let us see about the proposed work. According to WHO, in 2018, over 3 lakh women lost their lives and 5.7 lakh women hospitalized by the cervical cancer due to the ineffective screening of precancerous lesion in pap smear cell images. For this, we need an automated cervical cancer detection mechanism through the pap smear single cell image classification using 24x1 fully connected CNN. To concentrate on this research effectively, these are the major questions. What is the need to concentrate on pap smear cell image classification alone? And why does the approach for image classification in pap smear single cell images require to be an automated one? And how to make the classification algorithm more effective? These are the existing frameworks developed using a classification and regression trees, Bethesda system with ensemble techniques, Fourier transform infrared data with SVM, voting and the DNN classifiers, and convolutional net model. But the problems in these models are high computation, not cost effective one, hard to access, unreliability, and poor accuracy. To reduce these limitations, 24x1 fully connected CNN is used for better feature extraction through deep analysis of the images. So, we need to concentrate more on a stacked CNN. Let us see about this proposed framework. The input for training the CNN is taken from Herlev benchmarked dataset. It facilitates the research with 917 single cell images of pap smear cell. Data augmentation, which is the process, improves the amount of images through various operations like scaling, rotating, and reflecting the images to increase the size of the dataset. Layered CNN, which is used to improve the feature extraction by posing the images in 24 layers with various functionalities. Then finally a GUI, which is used for visualizing the output in a better manner and to increase the easy to access and reliable properties of this proposed framework. This GUI is used to visualize the output, that means the test dataset, or for predicting the new images for classification with accuracy and class identifiers. This is the simple workflow of the proposed work, in which the input images from Herlev dataset are augmented to increase the quantity of the data sets and also for training the model much better. Then these augmented pap smear single cell images are passed to 24x1 fully connected CNN to extract the features and to classify the binary classes correctly. Then it is visualized using a GUI. Dataset, in which the Herlev dataset is used in this proposed framework. This Herlev dataset is the 7-class benchmarked dataset of pap smear single cell images. First 3 classes in this table comprise the normal pap smear single cell, and the last 4 classes in this table comprise the abnormal pap smear single cells. It is an imbalanced dataset with 241 normal cells and 676 abnormal pap smear cells. This tabulation indicates the size of the nucleus and count of each classes present in the Herlev dataset. These are the sample images taken from the Herlev dataset with various characteristics like size, shape, color and deformity of the nucleus. These are the basic features used to classify whether the single cell pap smear cell is normal or an abnormal one. Then data augmentation. Data augmentation is the process of increasing the count of the input images by adding slight modifications like rand X scale and rand Y scale for scaling the images in a horizontal or vertical axis, and then rand rotation is used to rotate the images, and a rand X reflection and a rand Y reflection is used for reflecting the images. In this proposed model, we take the Herlev dataset with only 917 images, which is inadequate for training the CNN. So, we perform the data augmentation step and pass these augmented images to CNN. Let us see the 24x1 fully connected CNN. These are the 24 layers responsible for the various operations like convolution, rectified linear unit, batch normalization and max pooling, in which the hyperparameter is set to 100 and the learning rate is set to 0.01. Here the layers of CNN is analyzed using the Deep Network Analyzer tool in MATLAB. Finally, GUI is designed for visualizing the testing images with greater accuracy and helpful for predicting the new input pap smear cell images. First, we need to select the cell image by clicking on the browse button. The entire path of the image file along with the image content will be displayed here. Then we have to select the predict button, which displays the classification label along with the accuracy. This is the simple example for classifying the normal and abnormal cell. Here the figure A represents the normal pap smear cell images, in which the size, shape and color and deformity of the nucleus is normal one. But in figure B, here it is not normal one because the deformity of the nucleus is present in this image with size and shape which is a very large one and asymmetric over the shape, and the color is very light. Then finally we are shifting our attention towards the results section. I discuss about the results of the proposed model here. This table illustrates the accuracy of the proposed model in different epochs with base learning rate of 0.01. Here, if the iteration or epoch increases, the accuracy of the images to classify the normal and abnormal pap smear cell is also increased. For instance, if it is a single epoch and a single iteration, then the accuracy is only 69.53% with the loss of 71.01%. But in 100th epoch and 500th iteration, the accuracy is 92.97% with minimal loss of 0.1519. These are the performance graphs for illustrating the accuracy and loss of the proposed model. These are the performance metrics of the proposed system with the accuracy of 0.9020 and the sensitivity of 0.9358 and specificity of 0.8169, and all the other metrics like precision, negative predictive value, false positive rate, false discovery rate, false negative rate, F1 score are tabulated in this table using this confusion matrix. This slide explains the comparative analysis of the accuracy of existing model with this proposed one. Here, the classification approach using an ANN and SVM for cervical cancer detection by extracting the text-based feature have produced the accuracy of 88.2%, sensitivity of 88.8% and specificity of 85.9%. But this proposed model provides an improvement in accuracy and sensitivity sector with an accuracy of 90.2% and a sensitivity of 93.58%. Then finally the conclusion. Here, this proposed model achieved the accuracy of 90.2% and sensitivity of 93.58% and specificity of 81.69%, and this model provides a cost effectiveness for pap smear cell single image classification. But in future work, we had to consider the multiple cell pap smear images for testing and training. The input will be important. Then by implementing the NASNet architecture for the pap smear cell analysis with dataset of both by combining the Herlev dataset and the SIPAKMED dataset.